See, these 5 questions we are going to see. Yeah. Question number 40. Question number 40, you see, the critical temperature of water is higher than that of O2 because the H2O molecule has. These options are given. No, not 0.821. It should be as SI, so it should be 8.314. So what is the value of formula of critical temperature? 8A by 27 RB, correct? Yeah. So H2O molecule, you see, we know H2O dipole moment of H2O. H2O is a polar molecule. Dipole moment is not equals to 0. But for O2, the dipole moment is 0. It is non-polar. So the value of A, we know the value of A for H2O molecule is greater than to that of O2. That's the one thing. Okay. And it is given in the question that the critical temperature of water is higher than to that of O2 because of H2O. Obviously, if A is more of H2O, then its critical temperature will also be more. That is why, because water is polar. Polar means what? It has dipole moment. Hence, the answer for options of question number 40 is D. Yeah, this is the answer we have. Okay. Question number 41. The pressure exerted by 1 mole of CO2 is given, assuming that the volume occupied by CO2 molecule is negligible. Since it is given that the volume occupied by CO2 molecule is negligible, so we know B is for the volume of gaseous molecule. So B is 0 given in this question. You need to find out A, that is the van der Waals constant for attraction. So we know the van der Waals equation, P plus A by V square for 1 mole into V minus B is equals to RT. B is 0. So this expression becomes P plus A by V square into V is equals to RT. And when you solve this, you'll get V square into P plus, or sorry, I'll write down first this thing, minus R into T into V plus A equals to 0. So we'll get this quadratic. So when you solve this, you'll get V is equals to minus B, that is RT, plus minus B square minus 4AC. So 4 into A into P root over of it divided by 2A, that is 2P. Okay. Now what we need to do here, since it is given that pressure and temperature is given, so for a given pressure and temperature, volume must be constant. So it must have one unique value. For unique value of V, this must be equals to 0, plus minus term. This must be equals to 0. So from this, what we get, A is equals to R square T square by 4P. The value of R is 8 point. Acha, okay. Here, fine. Okay, Acha, for second one you were talking about, Kaushik. Okay, my bad, Kaushik. For the second one, it's fine, 0.821, because pressure we have, no, atmospheric only will take. In this question, question number 42 will take R SI value. Okay, 8.0.821 only take, because pressure we have in atmospheric, correct? So R is 0.821 here into T square is given 273 square divided by 4 times P is 34.98. See, the pressure is given in ATM, so obviously we have to take liter ATM per mole per unit. Okay, so when you solve this, you'll get the value of A, and the value of A you will get here is 3.6, around 3.6 you will get, 3.59. So which option is correct? Option A. This is correct here. Okay. Now, question number 42. Relative humidity of air is 60 degree and the saturation vapor pressure of water in air is 3.6 kilopascal. Okay. The amount of water vapor present in 2 liter of air at 300 Kelvin. Okay. So pressure is given. Pressure is 3.6. Yeah, you can take that 60%, right? So pressure is 3.6 into 10 to the power minus 3 Pascal. Okay, volume is given. Volume is 2 liter. 2 into 10 to the power 3, sorry, minus 3 meter cube. And temperature is 300 Kelvin given in the question. We'll find out the mass of water from PV is equals to nRT. So mass of water would be, mass of H2O would be P into V into molecular mass divided by R into T. So all the value will substitute 3.6 10 to the power minus 3, 2 into 10 to the power minus 3 into 18 divided by 8.314 SI unit into 300. Okay, so when you solve this, the mass you will get around 52 gram. Okay, relative humidity is given. RH is 60 degree, that is 60% is the limit relative humidity we have. So this is the mass of water. So the amount of H2O we have here in this sample, amount of H2O is 52 of 0.6, 60 by 100. That is 31.2 gram. Which one, mother? हाँ वहाँ पे correct, yeah. In question number 41, see the pressure and temperature is constant, correct, it's given. So for a given P and T, we must have one value of volume. We cannot have multiple value of volume, right? For a given pressure and temperature. So if volume has one unique value, it must be possible when the plus minus term would be equals to 0. And that is what the condition I have taken. Correct? So question number 42, the answer is this. Okay. 43, what is the answer? Three by two molar mixture of this and this means what? In the question it is given molar mixture of number of moles of N2 by number of moles of CO is equals to 3 by 2 given in the question. At 500 pressure, due to hole in the vessel, the gas leaks out. So it would be what? Molecular mass of CO divided by molecular mass of N2, root over of it into the pressure of okay. the pressure of CO, we have N2 here, no? So it will be the pressure of N2 divided by the pressure of CO. Okay, we need to find out what the composition mixture of effusion of this. Okay, so we have this number of moles 3 by 2. So if the 500 bar is the total pressure and the ratio of number of moles is 3 by 2, it means pressure of N2 would be 300 because 3 by 2 we have, and pressure of CO will be 200. So N of N2 by N of CO is equals to molecular mass of CO is what? What is the molecular mass of CO? 28. That divided by 28, root over of it, into 300 by 200. That is 3 by 2 we get. N2 by CO is 3 by 2. So NCO by N2 is 2 by 3. Option D is correct here. Clear? Okay, last one you see. '44. The number of N2 molecules present in 1 liter vessel at NTP when the compressibility factor is this. Okay, Z value is given. So Z is equals to, we can write PV is equals to nRT, PV by nRT. So you'll find out number of moles and then you'll get the number of molecules. So number of moles equals to what we get? PV by ZRT. All the value you will substitute because everything is given. NTP, the temperature would be 273. So this value, the number of moles, you'll get 0.037. So number of molecules would be what? Number of moles into Na. That is N into Na, which is 2.23 into 10 to the power 22. Option B is correct here. Any doubt in this? Okay, fine guys. So for hydrogen, you can solve all the questions of centum module. Centum module you must solve. Okay, NCRT you must go through once for hydrogen. Yeah, I'll share the class note, Madhav. Okay, I'll share. Okay guys, thank you so much. Take care. Bye.